Hey, algebra. Kind of a weird do now today, so it's a story. I'll read it to you. So my family was out raking leaves, and when my daughter was little, she liked to look at all the pretty leaves, and so she'd always pick up one at a time and look at it, and be, oh, look at the pretty leaf, and then put it in the bag. The rest of the family, we get the big rake the pile of leaves, and then scoop up the leaves with our leaf scoopers. So what we found out, we discovered that 10 leaf scooperfuls plus 36 individual leaves fills exactly fills 2 yard waste bags. And so I was thinking, like, man, I wonder what it would take to just fill 1 yard waste bag. I don't want two of them. I want to know what would it take just to fill one. So that's my question. What would it take? Scooperfuls and leaves. How many of those would it take to fill just one bag? I'll leave you to think about that. You can hit pause till you got an answer. Okay, so here's what I did. I said, look, I don't want 2 bags. I want just one. What if I just cut everything in half, right? Instead of 10 scoopers, what if I just had 5 scoops? And instead of all 36 leaves, what if I just had 18? And instead of 2 bags, I'd have 1 bag, right? Cut everything in half, 5 scoopers and 18 individual leaves makes 1 yard waste bag. There's other ways you could come up with this answer too. Anyway, but here's the deal. We're going to look at solving literal equations today. We've been solving literal equations for the past several days. Our learning target for today is you'll be able to solve an equation for y, which is a special type of equation. So literal equations, we've said, is basically any equation that has many variables. So this is just a special type of equation. So we're going to give this a different title. We'll just call this solving equations for y, which is still the same thing we've been doing. It's a literal equation, but we're going to focus in just on one particular type of equation. So let me revisit the do now to start with. So I wrote an equation for it. You certainly don't need an equation to solve this, but we had 36 leaves plus 10 scoopers, and that made 2 yard waste bags. And so I'm going to assume that every scooper had exactly the same number of leaves in it. Which I know it probably is not true, but we could make that assumption. It's not unrealistic. So I'm going to assign that to be a variable. I do not know the number of leaves in each scoop, but every time I scoop, I get the same number of leaves. So 10x can represent 10 scoops. And then for the yard waste bags, I know that a yard waste bag is obviously much bigger than a scoop. It's not the same thing, but I can make the assumption every yard waste bag will hold the same number of leaves because I just have this one kind of tree and every leaf is identical and it's going to come out the same, which probably is not true, but it's a reasonable assumption that we can work with. So I can have this equation. And then if I'm going to solve for y, like my directions ask, I would need to get the y all by itself on one side of the equal sign. Any other numbers or terms that show up there, I just need to get rid of them by doing the opposite operation. So I can demonstrate with this equation the exact same thing we just did a minute ago. I just need to divide this by 2 to get 1y. I don't want 2y's, I want 1y. And in order to do that, I'll have to divide every single part of this equation by 2. So instead of 36 leaves, 36 divided by 2 is 18. Instead of 10 x's or 10 scoopers, I'm going to divide that by 2. So that'll just be 5x. Equal sign comes down, and 2y divided by 2 is going to be single y. Yeah, it's the same thing that we said a minute ago when we were just looking at the pictures and the words, cut everything in half, right? Now I've done it with the equation. So solving is always the same, right? The process that we learned for solving literal equations is the same as what we're going to use today, where we're solving for y. It's the same as before that when we were looking at one-step equations, two-step equations, multi-step equations, equations that have x on both sides. The process of solving never changes. So let's just look at a couple of examples. Here's another one. What if I had one of these giant leaves in my yard, or a plant that grew leaves this big? The leaf is so big, this is hilarious. It's like bigger than this whole crowd of like 4 people. If I had leaves like that in my yard, that would not fit in a yard waste bag. If I was going to rake it up, like it's too big to rake. I'd have to cut it up into little pieces, and then I could rake the pieces together, and then I could scoop the pieces into bags. So here's what I pretend. Here's what happened. So I did that. 5 leaves fell. I had to chop them up into little bits, and then I raked and scooped those bits of leaf. And in order to get 5 leaves cut up and raked and scooped into yard waste bags, 5 leaves filled one whole bag, and then there were still 3 scoops left over after the bag was full. So 3x plus y equals 5. If you don't like the story, that's fine. We can just say, hey, look, an equation. If we're going to solve for y, I need to get the y by itself. So I found the y here's on the left-hand side of the equal sign. I'm going to leave the y alone. I need to get rid of this 3x. So to get rid of 3x, I need to subtract. And on the other side of the equal sign, I will have to do the same thing to keep this balanced. However, subtracting 3 x's, that's not the same kind of thing as 5 leaves, because the x's represent scoops. A leaf obviously is not the same thing as a scoop, and so I need to keep this in its own column. I do not get to combine the 3 x's with the 5. Sometimes people think, oh, 5 minus 3x, that's like 2x, because 5 minus 3 is 2, and leave the x on it, which, I mean, hey, you're thinking, but that is not how it works. So I had 3 x's, I subtracted 3 x's, those are gone. The y is going to come down to my next line, so is the equal sign. The 5 and the minus 3x don't combine, so I'm just going to write everything down next to each other. Y equals 5 minus 3x. Now let's try another example. This is a little bit more difficult. So same directions, still solving for y. The directions ask me to solve for y. Here's the y in the equation. It's on the left side of the equal sign, so I can focus just on the left-hand side to figure out what is it that I need to do. So I'm going to leave the y alone. I need to get rid of this 4. I need to get rid of this 2x. Since I am solving, I know my order of operations is going to be described by SAD, MEG. The first thing I need to do is either subtracting or adding. So that pretty much narrows this down. So I'm going to have to add 2x first. Add negative 2x's, added 2x's, those are going to cancel. Bring down this 4y to the next line. The equal sign comes down. 16 and the plus 2x do not combine with one another, so I just have to write everything down. 16 plus 2x. And then after subtracting and adding comes dividing and multiplying, and that's what I've got left. So the equation says 4 times y, and so the opposite of that is going to be to divide. So divide by 4, and then on the other side, I'm going to have to divide every single thing by 4. Just the same kind of thing as what we saw in that do now, where we had to divide every single number in that equation by 2 to make it work out. So I'm going to have to divide every single number by 4 this time. So on the left side, the 4's are going to cancel. I will have y. Equal sign is going to come down. So I can divide 16 divided by 4. That comes out evenly. 16 divided by 4 is 4. And then I also have to divide this 2x divided by 4. And that does not divide evenly. So you could use your calculator and get a decimal, but that is not going to set us up for success in the next unit that we're going to learn in the future. So we want this to be as a fraction. It'll make our work way easier in the future. So I'm just going to write down this as a fraction. So I'll have 2x divided by 4, or we can think of it as a fraction. 2/4 x. We can actually just slide that x off to the side of the fraction, so it's 2/4 x. That means exactly the same thing. And then we got to reduce this fraction. It's like an unwritten rule of algebra, all of math, really. Anytime you've got a fraction and you can reduce it, you got to reduce it. So that 2/4 reduces to 1/2. And there's my final answer. Y equals 4 plus 1/2 x. If you wanted to switch the order around of the two terms on the right-hand side of the equal sign, you could do that so that your variable, that 1/2 x, comes before the constant. This would be better in terms of math grammar. Our conventions say that we put the variables first. Either way is correct. But speaking of what's going to set us up for more success in the future, it's going to be better if we have the variable first. Okay, one more example. So we got a little bit more stuff going on here. So I noticed this time that the x is on the right-hand side, and in addition to that, it is a negative number. Okay, I don't really like to have negative numbers. Also, as it turns out, I don't really like having my y's on the right-hand side of the equal sign. And so a possibility is I could add 4y to both sides of my equation, just so that I don't want to have a negative y. And so if I do this, I'm going to have a positive y. Added bonus, it's going to move the y to the left-hand side of the equal sign, which is actually where I'd rather have it anyway. That's just a personal preference. Okay, so on the left-hand side, I had the 3, I had a 6x. The 4y that I'm adding is not a like term with any of those, so it does not combine. I'm just going to write everything down in a row, the equal sign, and then this 11 is going to come down here. Okay, so now I'm going to leave the y alone. Now that I got it moved, leave the y there. So I'm going to get rid of this other stuff. So I need to subtract the 3. The 3 is a like term with this 11. They're both just plain old numbers, so I can combine the 11 and the minus 3 together. So my 6x is going to come down, plus 4y, that's going to come down, equal sign comes down, and 11 minus 3, that's going to leave me with 8. Myself some more space. Next, I want to get rid of these 6x's. So I'm going to subtract the 6x's from both sides. 4y is going to come down. I don't need that plus sign anymore. There's nothing there to add it with. If I just write 4y, it still means it's a positive number, so I'm not changing anything. It's not like I just forgot about the plus. I consciously made the decision. I don't need to write down positive 4y. On the other side of the equal sign, the 8 and the minus 6x, those are not like terms, so I don't combine them. I just write them both down in a row. Lastly, divide by 4 to get the y all by itself. I'll have to divide everything on the right-hand side by 4. So those are going to cancel. So I'm going to have y equals, and then I'm going to have to divide both of these numbers. So let's do one at a time. 8 divided by 4, that's 2. That's easy. And then I have to divide the negative 6x by 4. So I'll just write it as a fraction for a minute, and then we'll reduce this. I'm going to call the 6/4 a fraction. I'll put the x right next to it. So I've got y equals 2 minus 6/4 x. And then I need to reduce that blue fraction. In this case, I recognize that both of these numbers I can divide by 2, and that'll work evenly. So I'm going to divide them both by 2. I'll write that down. And then that's going to give me y equals 2. That doesn't change. Minus. So the numerator, 6 divided by 2, that's going to be 3. And on the bottom, the denominator, 4 divided by 2 is 2. Don't forget that x. Okay. Before I finish, I will do the same thing I just said a minute ago. I'm going to switch the order so that my variable comes first. So you don't have to do this. It'd still be correct if you entered y equals 2 minus 3 halves x. But just to get us set up for success in the future, that negative 3 halves x I'm going to put in the beginning. It was a minus when I read it before, and I'm going to say negative. Really, they mean the same thing. Don't forget the x. And then this 2 is a positive number, so I'm going to put the plus sign in there. Y equals negative 3 halves x plus 2. Okay, so we're going to look lastly at what happens with some parentheses showing up. So if I have parentheses, the first thing I'm going to want to do is distribute. So I'm going to take this whole thing here, the negative 1/2 x, I'm going to multiply it onto both numbers inside the parentheses. So I'm going to bring that y plus 1 equals down to my next line. I haven't done anything with that yet, just copy it down. And then let's follow the red arrow first. Negative 1/2 times x, it's going to be negative 1/2 x. And then if we follow that blue arrow, negative 1/2 and I'm going to call this a -6. So when I multiply them together, negative times another negative will be a positive number. 1/2 times 6 is 3. And then my next step is I need to get the y by itself. So I want to take away 1. I have to do the same thing on both sides of the equal sign. These cancel. Y equals, so that -1/2 x still there's unchanged. The 3 and the -1, those are like terms. I could combine those by subtracting. 3 minus 1 is 2. That's going to be a positive number, so I'm going to leave this as a plus sign. And then we're going to circle our final answer. I'm going to use stars this time. All right, that's it.